Math is one of the highest forms of art. And yet, people see only formulas, numbers, and letters. They overlook the beauty of maths because they fail to understand its meaning. Just like art, mathematics can express and represent everything. It is the universal language that captures relationships and patterns in the world around us. Just like art, math is true freedom. Mathematics is not about the solution you find. It was never about knowing what x is, but rather about how you did so, the journey to solve. Through logic and creativity, you can solve every single problem. That logic and creativity is the essence of math. And if you think that problem solving is irrelevant, then you're wrong. If problems weren't solved, a lot of things wouldn't exist. Treatments wouldn't be invented. Technical limitations would not have been overcome. Technology of our daily lives wouldn't exist. Problem solving is an essential skill for any leader, and it is the key to innovation. Hello there, and welcome to The Art of Math. This is a series of episodes. Each one will present you with 2 challenging math problems based on a theme revealed at the end of each video. I'll teach you concepts and ideas about problem solving while making sure it is for everyone regardless of their level. This will hopefully sharpen your math skills and creative thinking. Now, without further ado, let us begin. ABCD is a rectangle with unknown area. N is a point from the segment BC. M is another point from the segment CD. The triangle ABN has an area of 27. The triangle NCM has an area of 12. Finally, MDA has an area of 15. Using all of that information, find the area of AMN. Since this is from a math Olympiad, no calculator allowed. Pause the video and try to solve the problem. Well, how was it? Were you able to solve the problem? I once again hope that you've grabbed a pen and paper and tried to solve it, since it's important that you give it a good try. Now let's solve. To solve problems, you must always understand what you need to find. Here, we're searching for the area of AMN, and by looking at the shape, there are not many ways to do so. Finding the height and base of AMN seems tricky, so we can't calculate the area that way. We are only left with one possibility, which is to find the area of the whole rectangle ABCD, then subtracting the areas of the other triangles. But how? Once you know what you're actually looking for, start by laying down the information you were given. ABCD is a rectangle. It means that all of its angles are right angles, and that AB equals CD and BC equals AD. We know this by the definition of the rectangle. This should hopefully be obvious for you. We know that the formula of the triangle's area is the height times the base over 2, because a triangle is literally half a rectangle. Using the visualization of the shape, which you should be able to draw on your own, let's write the formula of area for each given triangle. Here are our equations, but it's not ready yet. There are too many variables to be useful. Do you see how N is a point from BC and M from CD? This means that N is between B and C, and its length doesn't exceed BC. Thus, we can express either BN or CN as BC minus the length of the other. Same goes for M. Let's do it. Let's replace with these in our equations. Now let's replace every CD with AB and every AD with BC. After all, ABCD is a rectangle. We were already given the values of area for the other triangles, so let's input them. The 2 at the denominator is going to get in our way, so let us get rid of it by multiplying both sides of each equation by 2. From now on, we won't need the shape anymore. As you can see, we have 4 variables. Under normal circumstances, we would have needed 4 equations to solve for each variable. However, we are not actually looking for the value of a variable, but rather for the value of AB times BC, which is the area of the rectangle. To reach an equation with only AB and BC, let's use 2 of the 3 equations we have to express CN and CM. Take the second equation and divide by CM. That way we express CN using CM. We replace CN in the first equation. We divide both sides by AB, then we rearrange it. Since we want to express CM, we have to flip the fraction, but before we must write both sides as one single fraction. To get rid of denominator, we multiply by 24. We replace CM in the third equation. Now we expand. How nice! All the variables AB and BC are grouped by multiplication. We can replace their value by A, the area of the rectangle. The denominator is bothering. Let's multiply by it. We expand. Next, we move everything to one side. You can also reach this equation through any other choice of variable replacement and even addition. You may have noticed that the given areas add up to the greatest one. But it all leads to this equation. Now let the calculation begin. Here, everything comes down to mental calculation and the way we group numbers. In the worst case, you can use vertical operations. This is a quadratic equation. Let's plug in the expression to solve. We first calculate what's inside the square root. To calculate a square by hand, we use binomial expansion rules. How do we even calculate a square root? Well, there is an actually interesting trick I have linked in the description of the video, but through creativity, we can find it. The perfect squares below 10 are common knowledge. We can multiply them by 100 to get the squares of 10, 20, 30, and so on. Notice how 5,184 is between 70 square and 80 square. In fact, it's much close to 70 squared. So I know that it's between 70 and 75 square. All I have to do is test the remaining possibilities to figure which one is right. There it is. 72 squared under the square root becomes 72. the area of the rectangle is clearly greater than the sum of area for all triangles. Thus, we reject A equals 18. There we have A equals 90. We subtract from it the areas of the other triangles to get the area of AMN is 36. I hope you like this problem. Let's get to the next one. You're the manager of an animal facility with rabbits and foxes. Through monthly counts, you know there are currently 100 foxes and 50 rabbits. In order to effectively manage your resources, you need to predict how many months will it take for the number of rabbits to equal the number of foxes by using the data you've got from the 6 previous months. Assume consistent monthly birth rate. Pause the video and try to solve the problem. In order to solve, we need to understand what we actually should do to predict. This is about finding a way to express the growths than solving an equation. It should go without saying, but first, we have to note that the growth of a population is exponential, not linear. A linear growth of a population would mean that a small constant number of children is reproduced, and the population's number is getting added to the same number again and again. But that's not the case, whereas an exponential growth involves the many born members reproducing even more members, and the number of species is multiplying itself over and over again by the birth rate, which is more accurate and true. This is very similar to arithmetic and geometric sequences. But fear not, you don't need to know about them to solve the problem. Since the rise is exponential, and we have assumed the monthly birth rate to be consistent, we can deduce what the expression should look like. After labeling everything, we note that now is the starting point of the calculation. So the initial number of rabbits and foxes is 50 and 100 respectively. Furthermore, we raise the birth rates to the power of x to show that each month the number of species get multiplied by it. We can calculate the birth rate by dividing each number by the one from the previous month, then calculating the average between the results for high accuracy. Now that we found the birth rates, we replace in the expression, and we can now set an equation. Divide both sides by 50. As usual, we need the unknowns on one side, so we'll divide by 1.1 to the power of x. Since this is a division, we can actually factorize the power of x. Never do that in addition or subtraction though. We can use logarithmics. I'll quickly define how it works for those who don't know about it. Take log base 2 of 8 for instance. This means how many times do I multiply 2 by itself to reach 8, solving effectively 2 to the power of n equals 8, which is 3. Let's use it in our equation by following the same logic. X is the number of times I multiply 1.2 over 1.1 by itself to reach 2. Thus, x equals log base 1.2 over 1.1 of 2. We can enter this into a scientific calculator to finally get the result that x is approximately 8. If you don't have log base in your calculator, you can divide by the log of the base like this. So in 8 months, the number of rabbits would be equal the number of foxes. We can draw the previous expressions as functions to visualize it. The blue function represents foxes. The orange one is for rabbits. As we can see, they intersect near 8. Then the number of rabbits surpass the number of foxes. theme of this episode revolved around math modeling. You can represent pretty much everything of our world using mathematics. Many real-world problems are expressed through equations to solve. By the way, that first problem is the type of problems an architect may have to solve. The second problem is a good example of how maths can be used to predict many things. It's important to note that the solutions provided by models are not perfectly true. There may be some length miscalculation, the ignore of some factors that affect the result. For instance, assuming a consistent birth rate means ignoring every external factor and the age and gender for breeding. However, the solutions or predictions provided by models are still very close to reality and good enough to act on it. Thank you for watching this video. I have linked some additional resources and examples about math modeling along the square root calculation I previously mentioned. Feel free to check them if you're interested. Take care.